Question number 1, a unit may be stated with a prefix that represents a power of 10, multiple or submultiple. Complete 1.1 table to show the name and symbol of each prefix and the corresponding power of 10 or submultiple. Right. So here we have prefixes, and here we have what do they mean in powers of 10. So we know that kilo is 10 raised to power 3, tera is 10 raised to power 12. So you have to understand and learn your prefixes. You practice, do some problems, go through them once or twice, you tend to remember them quite easily. 10 to power minus 12 is pico, so it's P-I-C-O, and the symbol for it is small p. So that's your table. Next, in the following list, underline all units that are SI base units. Now, SI base units are those units that cannot be derived, right? Or they are not derived from other units. And those other units are base units. So they're the fundamental units. And the fundamental units are, here we have ampere, coulomb, metre, Newton. Now we know metre is a unit for displacement or distance, and it's defined as the SI unit. So that's one of your SI base unit. Newton is made from kilograms meters per second squared, right? That's what 1 Newton means, because we know that F equals ma, and force is given the unit of Newton. M is kilograms, A is meters per second squared. So Newton cannot be a base unit. What about coulomb? Coulomb is the unit for charge, and charge is defined as current into time that it flows, the current flows. So time has a unit of seconds and current has a units of amperes, and this makes charge give a unit of coulomb. So coulomb is made up of these two units, so it is not again a base unit. Ampere is a base SI base unit because current is the base physical quantity. So ampere and meter are your SI base units. Next, we have the potential difference V between the two ends of a uniform metal is given by this equation. So we have an equation for the potential difference between the two ends of a metallic uniform wire. So here we have these two ends, let's call it A, B, and the potential difference between these 2 points is defined by this equation 4 rho Li by pi d squared. D is the diameter of the wire, I is the current that flows through the wire, L is the length, and rho is the resistivity of the metal wire. For a particular wire, the percentage uncertainties in the values of some of the above quantities are listed over here. So you know that your percentage uncertainties for D is given as plus minus 3.0. For the current, it is plus minus 2.0. For length, it is plus minus 2.5%. And for V, it is plus minus 3.5%. Now, what does that mean? That means that there could be an error in the value for example, D, that could be either higher 3% or lower 3% than the original value. So if you go back to this next page, the quantities listed in table 1.2 have values that are used to calculate rho as this. So they're saying that rho has been calculated as this. For this value of rho, calculate its percentage uncertainty. So we know we had this equation V equals 4 rho Li by pi d squared. I can rearrange this equation for rho because I need to calculate for this value of rho the uncertainty. So that rho becomes pi d squared V by 4 Li. Right? Now, the percentage uncertainty in rho is defined as the change in rho divided by the original value of rho times 100. This is what we call percentage uncertainty in rho. So if, for example, you wanted to percentage uncertainty in L, then it would simply be delta L by L times 100%, right? So this is the percentage uncertainty in rho, which is equal to, we know that the rules basically, they come from taking a derivative of the above equation, but we'll not go into that detail. The rule basically is that here we have pi d squared V for Li. So pi is just a constant. We'll get rid of it. All the constants will get written off. So we're left with d squared. Now the power, when you take a derivative, it comes down. So this will be 2 times delta d by d. And that's for d squared. Next, if we have a multiply with V, we'll add it because the multiplication becomes sum and division becomes subtraction, right? And the power, so if I have any x to power n, the power multiplies with that x. In fact, it's delta x by x. So this would give me a 2 delta d by d plus delta v by v. And now we have division. So minus 4 is a constant, get rid of it. L delta L by L. By the way, don't forget to multiply all these by 100 because they are percentage uncertainties. So this is also multiplied by 100. Then delta L by L is also multiplied by 100. And then you have I. I is being multiplied with L, but it is in the division of this entire thing. So this would become minus delta I by I into 100. Actually, there should be a correction over here. Division does not mean minus, it just means sum. So basically multiplication and division, they are just sums. So this should be, all of them should be plus. And this gives you, if I put in the values of delta D from before, and we also have D, diameter, if you go back over here, in this is the percentage uncertainty in D, which means that this is the value of delta D by D times 100, right? And the percentage uncertainty in I, L, and V is also given. So you just put in those values. So this gives you 2 into 3.0 plus 3.5% plus 2.5% plus 2.0%, which adds up to a total of 14%, right? Which means that the percentage uncertainty in rho is equal to 14%. So that's the answer. What about the absolute uncertainty? Now, we're still finding this in rho. Absolute uncertainty is defined as the change in rho by rho, which means that change in rho is what? Or change in rho by rho is what? From the percentage uncertainty, we saw that change in rho into 100% or 100 is 14%, right? So if I take this 100 over there, this gives me delta rho by rho as 14 over 100. Now that is delta rho by rho. I want delta rho, which is my absolute uncertainty. So absolute uncertainty, which is delta rho, is then given as 14 by 100 multiplied by rho. But what is rho? It is given over here, 4.1 into 10 raised to power minus 7. So I can replace that with 4.1 into 10 raised to power minus 7 ohms meter. And then you do the math, and this gives you an absolute uncertainty of 6 into 10 raised to power minus 8 ohms meter. So the answer is 6 into 10 raised to power minus 8.